Hello everyone, this is Aritra back with you on my YouTube channel. I'm really sorry I was not following up with my channel and I missed making a few videos, but as promised, so I'm back again with you with one of the most anticipated videos about the data-oriented technology stack in Unity. So DOTS is not new. DOTS has been used in game development since like from the beginning, because games are greedy. Games are really greedy, and this is not like a generic application. So it's like having a dirty room, and if you have lost something, if you are searching for something, if you can just point out to that thing and you can just take it off. With object-oriented programming, you would have to walk to the closet, take it out, find that closet, and then like walk to that room, and then again come back and use it. So this doesn't work here with games right now, because games are really greedy. You want everything to happen real time, really fast. So right now, I don't know anything about DOTS, and in the end of the video, we'll make sure we both know about what DOTS is, and we will at least be able to make an Unity project with this new thing. I'm not sure what it means. So guys, before even talking about DOTS, which is the data oriented technology stack, let's talk about the C# job system. So guys, if you have been a loyal user of Unity, you'd know that there's a link called docs.unity3d.com, where you'll find a lot of articles written about the C# job system, multi-threading, and a lot more. This will help you to understand how the native Unity job system has been integrated on top of the existing C# job system. What is the job system? Well, it's a scheduler. It is just scheduling jobs for us. Like if you have been doing a 9 to 5 job, this manager who would like instruct you to do it at that point of time, and then he will shift a bit of his workload to another guy, like do this for me, do this for me, you do this for me, and what this helps is your job gets done faster when a lot of people are doing it all together, right? So this is a great way to make sure you're respecting the new CPUs with a lot of cores that are coming out. So the job system, built on top of the C# job system, this makes sure that you're doing justice to your CPU, because your job system would make sure that the execution threads which you're running on top of your CPU never exceed your cores, never exceed the CPU cores. What is a thread? A thread is imagine a thread like a part of the process. It's the smallest unit of execution of your program. So imagine in your mind, imagine it like you have a lot of threads. You want a lot of threads to run concurrently on your CPU. So great guys, so now that we know that the C# job system would help us write multi-threaded coding, which means we will be able to run a lot of threads over our CPU. So now we know that our code will be managed by the scheduler. We can decide which code to run on the main thread, and we can decide which thread to run on the worker threads. So this is a great way to do justice to your CPU as well, and in this way your job gets done faster. So now coming to data oriented technology stack, DOTS is all about data. You're feeding your computer the data, and your job is processing that data. So this is the main relation that you need to understand while working with DOTS. So every time, whenever we are working with DOTS, guys, whenever in Unity we are making writing a script using this DOTS tech stack, we'll make sure we have one component that is feeding the data, and one component which is like uh, handling the job system, which is processing this data. So now that you know that you can run your code on multiple threads, so if I say that I'm going to build a like character controller with which I'll get the keyboard inputs and move my character, I'll need two scripts, one to feed the input data and one to process this data. So I can write my input script. I can tell my input script to run on the main thread, because I don't want a lag. I don't want my job system or job scheduler to process this like with breaks or with discontinuity. I want this right now, right on that frame, so I can instruct my job system to run this thread on the main thread, right? And then I can, like, if I have lots of calculations going on, I can shift that bundle to worker threads. So in the most simplest of ways, Dots is like a sandbox for you where you can write your multi-threaded coding safely, because your C# job system is already taking care that the threads you execute are not exceeding the cores of your CPU, and it's really fast. And coding is fun. Coding is different. Coding is scalable in Dots. So what I have here is I just created a new Unity project which is not using any scriptable render pipeline. It is just the simple Unity project using the 3D. And here I'll start with creating a basic scene with a, let's say, a plane. Yeah, so I create a plane. Let me reset its position to 0, 0, 0, and also I'll add a cube on top of it, just like that. Yeah. So right now this is what the default system is providing in Unity. So while working with Dots, we need to make sure we have a few packages installed in Unity. So what we would do is, in the same project, we'll move on to the package manager, and after going to the package manager, what I'll do is I'll turn on this show preview packages checkbox, and then search for entities. And I'm sorry for the spelling mistake. Yeah, so I have this entities package which is in preview, and you can see the version here. I'll install it. I'll go and install it, and this is the first thing we need to get started with Dots. So after you have installed entities, it is time for you to make sure you have another package called the hybrid renderer. Yeah, so this hybrid renderer, what it would do is it would help you to render the entities. So using the entity component system, which is from the package I previously downloaded called entities, it would help my game objects to be treated as entities, and I'll need this renderer to render those entities, because once they have been converted as entities, they are nothing but a chunk of data, and they are not being treated as normal game objects right now once they have been converted into entities. So let's go and install the hybrid renderer. Now we have got the essentials, but I'm going to tell you about another package which we will not be using in this tutorial. It is the Unity Physics, and this is required. The Unity Physics package is required for authoring the Dots physics, because It is based on top of the dots framework. So for all physics related stuff like physics shapes and all, you require the unity physics. So guys, once I have got the essential packages for working with data oriented technology stack, so this is the very first thing we would do to our scene. We would convert our game objects, which is like this plane or this cube, to entities. And to do it, we'll use a script from the entities package that I downloaded, and it is called convert to entity. So we'll simply click that game object we want to convert as entities, and then we are going to add a component called convert to entity. We'll do the same for this plane. Okay, so let's do an experiment beforehand. So to let you know that how different it is, how different entities are from the default game objects in Unity. So you see this cube. If I am about to add a rigid body to it, so if I add a rigid body component to this cube, let me move it up just to make it look cleaner. Move up, yeah. So now that this cube has a rigid body, and once it gets converted into an entity, the rigid body and the box collider, all of these things would be converted to dots equivalents. All of these components that are attached to this game object would be converted to dots equivalent that we would be seeing in a minute. But to show you the difference between game objects and these entities, let's ask a silly question that whether entities can interact with game objects or not. So this plane right here has a mesh collider, and if it would have been a default cube with a rigid body, it will just land on the plane, right? But as soon as I hit the play button, it would take some time for the editor to convert this cube into an entity, and then let's see what happens. It will take some time for our editor to convert this cube to an entity, and nothing sort of happens right now, but you can see that the cube has gone from the hierarchy, and nothing, you cannot even select this cube in your scene, but you can select this game object. You can select this game object, you can move it around, and you can treat it like a game object. So this cube right now has been converted into a chunk of data. So how do we see it? For that, we'll go to Window, and then find, in the Analysis drop-down, we'll find the Entity Debugger. And after opening the Entity Debugger, let me dock it down somewhere here. And you can see there are two entities right here, which is the world time and the cube that we converted as entities. So once I select this cube, you can see the chunk of data that has been created and how it has been converted to an entity. So as I was telling you guys, that dots is everything about data. So the transform component has been converted into a translation value and a rotation value, and then we have this render bounds, which is from the mesh renderer, and then the materials, the mesh, and all of this. After adding the convert to entity, the game object components have been converted to the ECS or dots equivalent. Coming back to the editor, we see there is a rigid body attached to our cube, but it should fall, right? But nothing seems to be happening. Well, this is because we haven't installed the Unity physics yet. So to have a rigid body equivalent in dots, we would need to have the Unity physics. And just for demonstration purposes, we'll just get this from the package manager. So once we have our Unity physics installed, we try to find and try to locate the dots equivalent of the rigid body. So guys, now that we have our Unity physics installed, we'll see some changes with our editor behavior. And now if I go into the play mode, so it will take some time to convert the cube to an entity. So we see that the cube just falls through the plane, and this is a clear indicator that the plane, which is just a game object and it is not converted to an entity, does not interact with an object which is being converted to an entity. So I can just add the convert to entity component on top of this plane, and this will prevent the cube from falling down. So once I have added the convert to entity, let's take a look at our entity debugger right now. I'll hit the play button. I'll enter the play mode. Right now we have two of our objects being converted to entities. And notice the change here. As soon as you install Unity physics, this cube with a rigid body starts falling down, which means an entity equivalent of the rigid body has been generated. So right now in the play mode, we see that the cube is safely landing on top of the plane. If you go to the entity debugger, you'll see that you'll have three entities right now. The plane is there, and it is like showing the chunk of the plane which has been converted as an entity, and it is listing up the data. Let's take a look at our cube entity right now. You'd see there has been some changes. So previously this was not there. This piece, physics collider, physics mass, physics velocity, was not there. So once we added the Unity physics from the package manager, which is the dots physics, we see that there is a rigid body equivalent that has been generated and added to this chunk, and it is having a linear and angular velocity, and it is replicating all the rigid body characters in the form of an entity. So this is all just data. So entities is treating this whole thing, this cube and this plane, as data. So let's get back to our editor, and let's write a piece of code here. I want this cube to be able to move on top of this plane. So what I do is let's recenter the cube on top of the plane, and let's create a folder called scripts. And within the scripts folder, I'm going to write two scripts. One script, as I discussed previously, we'd need one script to read the inputs. It would hold the values that are necessary for moving. For example, the speed, or like the key you need to press to move, and all such information. So let's take, for example, I create a script called input data, and within this input data script, I'm going to write the data that I'll need for my player to move around, which would include the keys as well as the speed of the movement. So let's delete everything in the script. So let's just select and delete everything in the script. This is the default format of scripting that we have been using while writing object-oriented code. Going to add a few libraries using unity.entities. We need this to write our component data, and let's create a structure. Structures, as you know, these are collections of variables. Let's create a structure and name it input data, and we'll derive it from I component data. This is coming from this entities library, and let's define a few variables here, like public float speed and public key code up, down, left, and right. So guys, right now I want this structure to be visible within the Unity editor. So right now, if I hit save and I go back to the Unity editor, I want the script to be attached to my character, which is this cube. So I select the cube, and if I try to add this input data component, it would not show up on my components list. So for this, what I have to do is I would have to add a directive which is called generate authoring component. And now if I hit save, so back in Unity, I'll now be able to add the input data script to my character cube. And let's go and add a component. It already comes up as input data. Let's go and add it. So as soon as we add this generate authoring component tag or the directive, I like how this display comes up, like the variables that you declare as a structure come up. So let's go and set the speed to 10, and we're going to assign the up key as W, down as S, left as A, and right as D. I want the script to be very simple, and I want to show you how exactly all of this is going to take shape in form of a script. So right now this won't be doing anything. If you just hit the play button, this is just a data, and the entity debugger, you just see this as a form of data. So we now require to process this data and convert it into motion. So what we would do is write another script, and let's call it input processor, and this would have a job system to process this input data that we will be reading on the main thread. So I'm again going to delete everything from the scripts, and let's write it from the very beginning. Let's add a few libraries like the engine, and again I need the entities. Yeah, so now let us declare a class and call it input processor, and this time I'll be deriving it from the job system. So you'll see a red underline in Visual Studio, and what it is saying is it's basically asking you to refactor the code by implementing the abstract class. So I'll simply right click on this class name and job component system, and I'll hit quick fix and implement the abstract class. And I'm going to delete this line, because if you keep it like this, the Unity editor would throw this error calling it not implemented exception, and you really don't want your code to be empty. So on this job handle on update, I'm going to process the data that is here, and I'll use this data to make or to I'll use this data to convert and use it to move my character. So how can I do it? So in the input processor class that I created, which is deriving from the job component system, let's write a code like entities dot for each, and this is exactly how the coding is going to change for you from what you have been doing previously. So I'm going to write entities for each, and here I'll declare a local function like, let's write it like, let's put a semicolon here, and let's write, so I'm going to update the position and the translation information of my translation data of my character entity. So I'm going to I'm going to need another library called the unity.transforms, and this would give me access to the translation data. So I'm going to update the translation data, so I'm going to write it like ref translation, and let's call it translation just as it is, and I'm going to take the input from the input data struct, which is added as an entity to my character. So I'm going to take inputs. I'm going to read the data from the structure. So I'm going to write it as like in of our type input data, and let's call it data. So now I can write the body of my function. So now that we have declared all these variables and we have the data with us right now, we can write a piece of code within the entities for each block as translation dot value dot z. Notice how the coding is changing here. Notice how the style of coding is changing here. Rather than updating the position, we are updating the translation value of the cube. So I'm going to do it like translation.value.z plus equals, if you're pressing the key up, I'm going to add the z value of my translation by data dot speed, and if not, I'm going to add 0. Similarly, we can write it like translation dot value dot z minus equals input dot get key data dot down and reduce it by data dot speed, and if not, 0. Again, translation dot value dot x plus equals input dot get key data dot write. We are going to add data dot speed again. If you are pressing the right key, it is going to move this amount of units per frame. And if I add, and I need to add another axis, which is the negative x-axis. So I'm going to write it like input dot get key data, and this time it would be the left key data dot speed, and if not, 0. So right now you see we are not using, and you can already guess the mistake in our code. If you are going to do this, This is going to take our cube like ooh, and so we need to add we need to multiply the speed variable with time dot delta time to have a really smooth motion. And we know that we need a frame rate independent motion, so we need to multiply this value with time dot delta time. So what I'm going to do is, before processing this for each block, I'm going to take the frame I'm going to take the delta time for that frame. So let's call it delta time equals time dot delta time, and I'm going to multiply this value here. Let's multiply it here again, here again, and here again. So this looks complete right now, but we still have something to do. So I told you that now that you can write multi-threaded coding using the job component system, you need to tell your code that where you need to run this thread on. So this is doing input operations. Since you are doing input operations, you want it on each frame and you don't want a discontinuity. So I'm going to run this thread on the main thread, and to run this on the main thread, I can just ask this for each statement to run on the main thread, and what I'm going to do for it is just simply write dot run, and this would run my system on top of the main thread, in the main thread. And here I need to return this job handle because I need to tell the other jobs that this current job has been finished. So I'm going to return the state of this job handle. Let's call it new job handle. Let's leave it like this. But we are still not done, guys. When you're running code on the main thread, it is really important to tell the other worker threads, the other sequence threads, that your job is really complete, and you need to optimize. And to optimize the sequencing of these jobs, you need to give an instruction to Unity that synchronize this job with other jobs. So I'm going to add a directive which is called always synchronize system, and this would make sure that my job works in a very optimal manner with other concurrent jobs that are running on that thread. So right now, if I go back in Unity and let my script compile, so I'm going to update this. Okay, I've already added a few values here. I have added the speed like 10. So now that I have added this input data ordering script here, which is barely a block of data, and you have an input processor which is processing this entity data. So right now, if I hit play, if I try to move my cube with the WASD keys, it works. It works like it should be working. And I think I need to reduce the speed a bit. Let's call it 5. And the fun about dots here, guys, if you keep on duplicating this cube, let's say Command D, let's move it like this here, and let's place a few right here. Let's duplicate all of these here, and I'm going to fill my scene with these cubes. Like this, and now if I hit play, let's position our camera like this, somewhere like this. I'll select my main camera and align with view. And let's go into the play mode to see what happens. So now you have a bunch of cubes, and if you try to move them, they all run on the same frame rate. So it is the same frame rate as we were using when we had just one cube. You see, we have like 133 cubes in the scene. Some of them are within are inside the cubes. That is why the number appears less. So right now I have kind of like 397 cubes with a movement script attached to all of them. So this is the fun of dots. Let's add materials to this cubes. Let's create a new folder called materials and create a new material. Let's call it cubes. Let's create a material and like change the color to red, and we can select all of these cubes here and assign the material we just created called cubes and make it all red. So right now if I hit play, I can see all of these 397 cubes moving at the same frame rate as before, and all of these are having a physics body attached to them. Can you imagine? You cannot simulate more than 397 rigid bodies together using the default editor or using the default way of working with game objects. So this is the power of converting to entities. So I hope it was really fun doing this little task of getting started with dots, and you can try playing around with the translation data. So if I tell you to go back and check the entity debugger, if I go back to my entity debugger, you can see that for each of these cubes you have these values like the rotation, the translation, the physics mass, the physics collider, the physics velocity, and you can play around all of these things to come up with a simple game, a very, very simple game. And I think this right here is the most basic way you can start using dots today. I hope you guys really enjoyed this tutorial, and I'm going to come up with more detailed tutorial with a lot more new things to do with the data-oriented technology stack. But this right here, I'll add a few learning materials to the description of my video, and this is going to be the perfect start for you on dots. This is like a one-day practice, one-day exercise for you on understanding how the dots, how the ECS, and how the job component system have been integrated all together to work with Unity. So guys, I really need to tell you this. My show, Indie Wild with Aritra, is accepting submissions for its episode 2, and we are going to the video is on its way, and this time it is going to be a lot more interesting, a lot more game developers to showcase, and this time I'll be live reviewing the games. So this is going to be really, really fun. And so if you were not a part of the last episode, please submit a game. I'll tell you the ways you can do in the description below. Please make sure you check the description out. I know it's really hard work, but I should have mentioned it here. I should have mentioned the steps here, but do a favor for me, like just scroll down and check the description, and that's how you are going to get your game featured on my YouTube channel. So I'm ending this video here with love from Unity.